It's only, we come with our modern rich system, why not stake it out, we have to survey it.
Christina, we're here in your room.
Good morning, everybody.
Good morning, Nathaniel.
Morning.
Congratulations. Thank you very much.
Oh, you're welcome. Thank you. Congratulations to everyone else as well.
It was fun.
It was. It was crazy here.
Yeah.
I heard Cleveland got really nice views of totality.
It was incredible.
I'm so glad.
The weather was just phenomenal. We woke up to rain and heavy clouds, and then it just about half hour after the SEQP started, everything just disappeared. It was unbelievable.
And
That's
the New York Times today has traffic maps. Nobody came to Cleveland, so we kind of had to ourselves.
That's fantastic.
People filtered in over the weekend, but then they all left at once.
That was not true of northern New England. We got swamped.
I'll put up a click to that article. The maps are really amazing, and yes, you guys got swamped. We didn't.
Northern Vermont, but it took 9 hours to get back to Boston. So
Yeah, it took me 6 to get from northern Vermont back to
That's
my
why I
house.
said,
yeah,
fortunate.
Some of us waited to Tuesday.
Yeah,
yeah,
but did you guys see totality and see the corona and all that?
yeah, we did.
Oh, yes.
Excellent.
One thing I was wondering is the view of the sun. Yes, I saw a prominence in the lower left. The people down in Texas, is the sun oriented the same way, or is there a rotation involved?
Good question.
Slight rotation because it's a little bit different time of the day.
Was
So
the
does-
prominence on the sun, or I've been reading about an effect called Bailey's beads that talks about valleys on the moon where some of the corona snuck through.
Yeah, we saw that too, but there was a very large prominence.
Yeah,
Okay.
lower left from Vermont.
Yeah.
I didn't see so much beads on the front end, but the tail end.
I like the way that all the stations agreed that, oh, look, something big is happening. All the stations in New England, at least.
Yeah, I sent the the Grape 2 plots out too for 8 stations in the U.S. In the eastern U.S. I don't know if people saw that, but those are the Grape 2 10 megahertz plots,
And it's
which
so
coincides with the New England plots pretty well. So
I'm going to go ahead and share them.
I'm sorry, go ahead.
Reminiscing and things. And if you'd like, there's a section in the minutes just down at the bottom where everyone can add photos in and things.
Nice.
I also sent out a link to a Google photo album where you can post photos of the eclipse and the SCQP as well. Did you have that in the minutes by any chance, Rachel?
I don't, but I can add it.
Okay, do you need the link, or do you want me to, or do you have it?
I can dig through my mail for it.
I'll go grab it. It's easy for me to get. And I can put it in the chat.
Perfect. Okay. I do believe here. Does anyone have any other announcements? Now that we're not on I should probably say CEDAR for non-students is currently accepting submissions. I think, I guess Phil will tell me if I'm wrong. they're still accepting, no, workshop proposal submissions are due already, but they're still, they're still accepting registrations. Alright. Does anyone else have any other announcements? Because if not, we'll get right back to the eclipse.
AGU is finishing up its deadline for conference session proposals. The Washington meeting this December.
Look at those.
Did you have one in mind?
Us?
Yeah.
Yeah, okay.
Well, let's see.
My general feeling about AGU
Mhm.
conference sessions is this. Liz McDonald over the past few years in Aurora Source has done a great job organizing the MacGyver session, which is really good. I'm sure there's going to be a session on the eclipse at AGU. I actually generally do not like organizing a specific session for citizen science because I like figuring out how the citizen science can fit into the other regular sessions, because that way it makes it look more like we're doing actual science rather than trying to just do our own citizen science. But that's just my personal opinion. And it's also just based on my amount of bandwidth for being able to organize yet another thing. So
Totally fair.
So something I do recommend is, when the AGU sessions come out, one of the things we should do is we can figure out which AGU sessions do we fit into the best. And I'm sure there's going to be an eclipse, probably multiple eclipse sessions at AGU. With all of that
Deadline
said,
for AGU?
with all that said, if there's someone who really wants to, like Rachel, if you're like, yeah, I really want to organize an AGU session, it is a great way to like create a rallying point around the type of science that you're interested in. And it's also, it can be a good career development thing as well. So, there's different ways to look at it.
When was the deadline for submissions for AGU?
For a whole session, it's in about a week. Take a look at the click that I put in chat.
Okay, thank you.
Is there any reason that we would want to, I guess I would say, follow up from past sessions or presentations we made to kind of continue the story? Or
Well, we absolutely do. I mean, that we absolutely want to continue the discussion of things that we've done. I guess the question is there someone who wants to organize a whole session with our own theme?
Yeah.
My personal opinion is we want to spend our time. We spend a lot of time organizing the HamSci workshop.
That's fair.
I think we want to spend more of our time focusing on how to actually get peer-reviewed publications out and actually create good presentations to show at AGU, because that's, I think that's really where we need. I think that's potentially the weak area that we have. And that's also the area that if we are able to get peer-reviewed publications out the door, that's what's really going to really set us apart from other, you know, from other types of large scale or I don't know. I think that's the thing that really needs to happen to make sure we're really recognized as an effective citizen science project.
Yeah. Let's see. Let's see if there's a list yet of all submitted workshops. I will post the list too for CEDAR workshops, so people can start thinking about which workshops we should maybe like drop a line to.
Does anyone in this call live in the San Diego area? No, that's where CEDAR is going to be this year.
Yeah, I think I've got kind of a little bit of a timeline going for it. Because luckily the eclipse was wonderful. I do think we should probably show some graphs. And I know Kazdan wanted to show some graphs as well. So after CEDAR, we'll have Hamvention, or not after CEDAR, but I think the next thing after that is Hamvention, then CEDAR, then Age.
Yeah, Hamvention's coming up fast.
It is.
Yeah.
Wanting to be there. Just a quick aside while things are quiet. I need to get a new lab coat. Mine says it's a large, but it fits like a super small.
Oops.
Can you post a link for that again, Nathaniel?
I'll find
Yeah.
it, David. I'll post it in a minute. Yep, let me look, because
Okay,
I need
great.
to update the Hamvention pages anyhow for the site, so.
Yeah. Why don't we also, since no one has very strong opinions, I'll go ahead and let David share some plots. And I will pull up some great plots to look at just as a bit of a victory lap.
And let's see, do I have screen share? I
Yes.
think so. Okay, I got we're not going to see as many CHU plots as we're going to see WWV, so I thought I'd mention one interesting one that we got early. Ottawa is in the upper left here. Lake Saranac is in the lower right. And here is, he said a little louder, here is, where'd it go? Here is, yeah, here is a graph of CHU 7.85. It's certainly pretty obvious where the eclipse is. So this is interesting. It's just across the eclipse path from CHU. This is only about 100 kilometers. And I wouldn't have expected so much change in a fairly direct path. But okay, there you have it. We had this is a Doppler plot, and who could have guessed, but he had the Doppler range set too narrow here, 3.8 hertz up and down. We did time of flight from the second tick along the path of the eclipse, starting in Austin through Little Rock, St. Louis, Indianapolis, Cleveland, Toronto, and then a control station in Ottawa. We had a live feed coming from those, and it's just astonishing. The lower frequency signals popped out of the noise pretty much exactly at the times that you would predict from the shadow crossing the midpoint of the path. Everybody was delighted. The Austin and Little Rock radio clubs that helped us were high school clubs ranging down to ninth graders, and they were utterly happy. So that's what I wanted to show off.
Hey,
That looks really nice. I have some thoughts I can show too. Go ahead, Bob.
I was just gonna mention, I've got some CHU 7.85 plots.
Anything interesting?
Well, it went, the other thing that was interesting, and I don't think it's related to the eclipse, but the Doppler was jumping all over the place during the night before. The CHU has proved to be a very interesting path from here. The signals just go every which way at all times. It's just unusual to see a signal that is, you know, fairly close, doing such wide gyrations and dropping out when you really wouldn't think it would and stuff. But
Yeah, I've been recording.
but there's a very, very dramatic S curve or whatever you want to call it right at the eclipse on the Doppler of about 1 hertz. That's all I've got.
Did you show that?
No, not easily.
Okay.
It's on Bill's.
I
No,
can
it isn't on Bill's, but Bill could put it on.
I can show my second tick time of flight to Cleveland if you want, but it'll take me a moment to queue it up.
Oh, look, Bob.
Oh, I got it, Bill.
Okay.
Thank you for sending it out. If I can get my mail working, this will take a minute. On the 8th, where was it?
I'm sharing some plots in a minute, so we can go back to those if you'd like.
All right, I do have that time of flight plot up if you want me to show it.
Sure.
All right, some of you have seen these. This is the the CHU second tick time of flight. It's the voltages coming out of an AM detector. And the usual story here. I'm sorry. Let me get the I'm sorry. What I don't have here is the eclipse properly centered on the page, and I'm having trouble finding it. If I can't get it quickly, Rachel, go ahead. And
19, 18.
Okay, did that help?
Is it that wobble pre 20 UTC, I imagine?
Yes, almost every day there's little there but noise at that time. The signal came out of the blue before totality time here, had a substantial wiggle. After totality was quite turbulent, and then kind of came back to its late day pattern, its usual late day pattern. So yeah, we had a very nice result here in Cleveland, and again, it was all along the path.
That looks really nice, David.
On all 3 frequencies.
That looks gorgeous.
Yeah, thanks.
You're welcome.
So the eclipse is the part 19 through 20 UTC?
Yes, we had totality at 1915, so about where my cursor is
Right.
here.
So the signal came in, wobbled, and then went away.
Correct. And we've been surprised on all of them how much before totality there seemed to be effects. So we're making a wild guess on the basis of not very much, that maybe this represents the bow wake that we've talked about over the years, but I have no way of stating that. I hope someone else does.
That looks great, David.
Yeah, this was very cool. No way around it.
Other frequencies too?
Yes, all 3 of them. They're different ones had different prominences in different places, but yes, we had interesting results on all 3. For what it's worth, we added an octave to it by having W8EDU beacon on 10 meters CW. 10 meters was so long the entire time that we couldn't see any pattern from the reverse beacon network there. We also added another octave with John Ackerman's 6-meter beacon in Dayton. We didn't, as far as I know, we didn't hear it at all in Cleveland.
Here's the plot that Bill set out.
That looks really nice.
Yes.
Yeah, that's amazing.
This is from North Carolina, New Hampshire, Tennessee, Kentucky, Florida, Alabama, Ohio, and Massachusetts.
And ours in Cleveland looked like this too, and I don't understand it because the eclipse was not between WWV and us. We were on the path.
Yeah.
Right, backscatter or something.
But about the same thing and the same deviation level.
Yeah. Well, I
out here
think
in California, both we and WWV were west of the line.
But I also think that you know, when we talk about this optical effect, you know, we make a really big deal as to whether you're in totality or not in totality. And I think when it comes, my suspicion is when it comes to the ionosphere and the radio effect, it becomes less important whether you're actually in totality or if you're beside totality. Because like here in Scranton, you know, we got 95% eclipse. And I think maybe at the ionosphere, that's pretty, the ionospheric level, that's pretty good. And then probably even if you're west of the eclipse path, you know, you're still getting quite a bit of eclipse, even if you're not right in totality. So it doesn't totally surprise me that stations that are not crossing the path would still see an effect.
Certainly that North Carolina is way off the path.
Yeah.
But it of course is across the path to WWV, but
Well, what I was impressed with by, I don't know if you guys saw the exchange yesterday, but someone in California was asking about what he called the thump. And he didn't even have, he was, you know, on the opposite side of the eclipse between him and WWV, and it saw it very prominently.
That's what Art's describing here.
Yeah.
I should have prepared for this, but the Alaska Anchorage 5 megahertz signal did some gyrations up there. Now
Yeah,
I think it's probably listening to either WWV or WWVH. It's probably the longest path in the US network on WWV.
I can show that,
Can you
Bob,
show that, Bob, Bill?
as well as your CHU station. Hang on. So
You
the
go-
green is Alaska, Anchorage, 5 megahertz. And it does this before, well,
Yeah,
and then when the eclipse is happening, it's just dropping in Doppler,
but it didn't see a big negative, positive, negative.
right?
Yeah, it's
I mean, unless you consider that to be it.
No,
I mean, one of the things that I found striking about it was that it was so nicely centered, and, you know, so symmetrical.
Yeah,
exactly.
By the way, one
And-
of the places where the gods smiled on us is we got no flares.
I know.
We got clean data.
That was really great.
here's the red line is CHU and at Groton, Mass. So, Bob, that's
yeah.
it looks displaced on 7.85 from the majority of the other stations. So it's like, you know, the null was an hour later, the peak was an hour later. Interesting.
I got a lot of coax.
Oh, yeah, that's it.
I got basically the same pattern out here in northern Arizona. Yeah, basically a second dawn.
Yeah,
Oh, yeah.
Yeah, as a reminder, let me show Nathaniel's animation of where the eclipse went overhead. Let me see if I can share here. So we talk about the path of totality being only 120 miles. This is what, at 300 kilometers altitude, the eclipse had significantly more coverage, if you want to call it that.
Right, and it's not, this is not just showing totality, this is showing percentage obscuration.
Right. Nice.
Oh, I'm sorry, we lose that.
Where it went.
I'm looking at our station in the Netherlands, and it's been suggested that the delayed thump, I'll just call it that, observed in the Netherlands might be related to the movement of the eclipse Earth track in their direction, which I will admit I hadn't seen, because I hadn't really seen a map that seemed to take the track out to its end. Does anybody know where the track ended on the Earth's surface?
It
I don't know
showed
if
it
it
in
goes off an edge or just, tapers off
well,
to nothing.
it shows it in Gary's, in the animation Gary just showed. Gary, if you want to bring that up again. And one of the things that you have to realize that where it ends, that's where it starts going into nighttime. So you can't have an eclipse at nighttime.
Oh, how about
I'm working on it.
yeah, it's right
I
at the
closed it.
terminator.
Can't have an eclipse at nighttime.
Yeah.
Is that right?
A lunar eclipse, sure, but
Yeah.
Not a solar eclipse.
Right.
Well, you
No,
don't get you don't get a visual experience of it, but
well,
can we
the-
not
the-
still be in
the
a
last contact is at sunset.
yeah, go ahead and roll it out. You'll see that it just
no, the Earth is turning,
yeah.
and it just turned.
And
enough
so we get that
shadow just hit
smearing
the-
effect.
So last contact was out in the Atlantic.
Yeah, just below Iceland, it looks like.
May
Okay,
I show some of my plots?
sure. I had lined them up in the minutes, but you probably have them at better resolution.
Oh, sure. So this is from the Whisper Demon.
Nice.
Yeah. So this is from the Whisper Demon Grape-like data. And so we got 9 bands. So we've got the lowest frequencies on top. So this is WWV, WWVH at 2.5 megahertz heard in near Scranton. You can see like a little enhancement there, right there. So I would bet that's the eclipse. You have to squint for that one. But here's a CHU on 3.3 megahertz, really beautiful eclipse signature. And you simultaneously get both the eclipse and you get what I think is probably the E region path at the same time. And I'm only like 250 miles from CHU. So this is a pretty close path. And there's the power enhancement. Then here is 5 megahertz WWV. You get primarily the E region, which is primarily unaffected, but you can see a little bit of the eclipse in there. Then this is 7.85 megahertz CHU. So we get, this is a little funky, but that's definitely eclipse here. I'm not sure what's going on over there. It looks like it might have gone below the maximum usable frequency. So we got some very interesting signatures there. This is 10 megahertz WWV. This is pretty much the classic signature I'm used to looking at, so that's absolutely gorgeous. And we get nice enhancement in the received power levels on 10 megahertz. Here's 14.6 megahertz CHU. Again, more of a classic type of signature, but it's very diffuse all day long. And then this is 15 megahertz WWV. And again, we get, it's a little different than I'm used to seeing. So almost it like goes down for a long period here, and then it goes up and then down, and we lose some signal, and then it kind of comes back. So that's a little bit different. But I think this might be like an MUF dropout. Here is, yeah, but I'm still not entirely sure how to interpret that. This one I thought was very interesting. So this is 20 megahertz. And here we've got like two things going on here simultaneously. You have the more classic like eclipse signature that I'm used to seeing in the thin line, and the thick red line, it like increases in Doppler and then decreases. So that's like something I'm not used to seeing.
Well,
And
looking at that, I see WWV and WWVH.
Yeah,
that's
that'd be
very
my take.
possible.
That's the sort of dual plot. Although at this location, one of the signals, and so I'm presuming it was WWVH, was
Yes.
absolutely dead on zero Doppler throughout. So on my plots, there's this thin horizontal line behind the classic plot.
Kind of like what I see over here.
Yep, but that could be E reflection, which is very stable.
Right.
And you're in California, Art, right?
Yes, I am.
So I think in the Grape 2 data, I should have the same channel there, and I should have the wider bandwidth. So when I get to looking at the Grape 2 data, that will hopefully help us disentangle the WWV, WWVH thing. But I thought this was a really interesting signature. And then here's 25 megahertz. And this really shows that classic like muff dropout that
Wow.
the New England Grape
That's
Group
beautiful.
talked about.
Yeah.
Boy, the ionosphere showed you the full Monty, so to speak. In your lowest frequency ones, can you make a guess that that's delayer that you're seeing there?
Delayer absorption?
Or the cessation of it?
That's delayer going away.
Yeah, I think that this is delayer going away. That's my guess there.
We saw it very clearly in our AM broadcast reception.
You know, I
Yeah,
did try to listen to Clear Channel stations during it, and I didn't hear anything from Cincinnati or from Toronto in Cleveland.
Could you step back and explain the delayer going away? I mean, it's almost like you're proving a negative. I'm having trouble understanding the plot.
Well, the delayer is powered by the ultraviolet light from the sun.
Right.
So as that goes away, the delayer recombines and the absorption drops.
Very rapidly.
So signals would be enhanced at that point because you've got less absorption,
Correct.
right?
Lower
Okay.
frequency signals have a distinct enhancement. And we saw the background noise level come up very prominently in our
Okay.
AM
So
broadcast
that's where the
recordings.
signal appeared at 5 megahertz. Okay.
very clear here on my CHU plot at 3 megahertz.
So it sounds like we're seeing pretty much what everybody expected to see.
Yeah.
Did we see anything new here?
Well, I think that's what's going to be really tricky to tell, because the things that we expect to see, we know to look for them. And the things that we aren't expecting to see, well, like I don't know how to explain this kind of two signature thing. And yes, it could be WWV and WWVH, but still, like, this red line looks it's not a signature I'm used to seeing. So I really don't know.
Actually, that is not WWVH. They do not broadcast on 20 megahertz.
That's useful.
Okay, that's
So that's
interesting.
two different layers we're seeing.
Ta-da, nice.
Or it could be ordinary and extraordinary wave.
Yeah,
But those are off by an hour. That's pretty long for
I mean,
extraordinary.
yeah, it's definitely, I think this is one I was not expecting to see. What does it mean? I'm
that's
not
good.
sure.
If Nathaniel is stumped, that's a good sign. I think that gives us,
Yeah, that's
Well,
one for Phil Erickson to
Here's,
explain.
here's the one we can't explain.
And so there you go.
Yeah, I
But
always like the
I
line.
really like that one.
I always like the line that's attributed to Isaac Asimov, but probably isn't his. That science does not
Because-
progress by eureka; it's by that's odd.
But the two signals don't show up at the eclipse. They're through the whole daytime path,
Yeah.
it looks like.
Yeah, look at that.
Who
Yeah.
is that?
There are two
Well,
definite
was.
patterns.
Whatever it was affected by the eclipse, it seems. There's a correlation, but there's an hour difference.
But Bob's right. Like we also see this one's like wandering around.
You know, I think it's aliens.
well, we're probably seeing a future peer-reviewed paper. You saw it here first on the Grape call.
It's
That's
exactly
the
what
U2 following this eclipse.
that's right, or another grant to study it.
Well, it would be interesting to look at a previous or following day for the same path.
And
I
other
agree with
stations
that.
and all that sort of thing.
I agree. So yeah, it was very, very interesting.
Food for thought, as they say.
My takeaway is the entire group ought to be feeling pretty good right about now, really.
I agree.
Most observed eclipse in the radio ever, probably.
I think in human history is what the press has been saying.
Well, there's a definitive source.
Some and some.
Touche.
It's Steve Serwin. Yeah, you can keep going. You can keep going. I'm going to talk to Steve Serwin really quick.
Okay. I think I managed to catch most of the plots in the minutes. Hang on. We do also have Grape 1 DRF, just single stations things. There was a whole bountiful harvest on the personal space weather station network.
Rachel, do we have a feel for how many different stations covering the different modes, FL-Digi and the Grape 1 DRFs and the Grape 2s actually took part? In round number, but
We probably had at least 30 Grape 2 stations. In terms of the full grapes, that's probably easily another 15 or so. I'm not sure how many whisper stations there were, and as we see from all of this, the whisper stations produce a lot of data. So, yeah, I'm not honestly sure how many stations we had. And the Grape 2 station will also produce data that can be directly compared to the Grape 1 data. So I guess we'll see.
Well, as I remember, there are more than 60 Grape 1 node DRF nodes numbers given out, so maybe there's a
Yeah.
lot of them.
Well,
Stan counted 52 Grape 1 DRF stations active yesterday, right, Stan?
Something like that, a lot of green pins.
Yeah,
yeah,
there's only 51 right now, but 51
And there's-
green dots.
easily about 50 lines in the personal space weather station, like readout for available data for that day. That does include magnetometers.
Yeah,
That's
Um,
amazing, given that John Gibbons thought that would be just a one of.
Hmm?
The
Yeah,
Grape
that's-
one.
The Grape one.
He thought it was just gonna be a little prototype. Like,
Yeah.
look how many
Here's
stations there are.
Here's a question for the floor. Where do we go from here? Is there any thought or plans for continuing with more Grape 2s or maybe redeploying those that aren't being used right now?
That's right. It's
Oh.
tomorrow. Back to work.
I'm sorry, say again?
It's already tomorrow. Back to work.
Yeah, I know. That's right.
Actually, Christina's here and maybe an appropriate person to talk about this because there is the next YASI grant round coming up. I would personally like to see the network built out a fair clip, even if that means going back to kind of cheaper, more distributed receivers.
Grape 1 DR, Grape 1 FLW works just great.
Yeah. Christina, did you have any updates on what you were thinking? I thought I spotted you in the audience.
I think she dropped out. She had a in-person lecture.
Oh, okay. And Frizzell dropped out too. Might be the most appropriate to comment on what that particular stuff would look like. Is it May 15th or May 1st? To a certain extent, though, building out the network would still be very, very helpful because even if there's not a solar eclipse, our ionosphere is still a really complicated system.
Yes.
And at the moment, I think if we just like compare the Giro map, we probably have more, grapes in the US for sure right now than we have ionosons.
Also, there's going to be eclipses over the next couple of years, but we're not there, but maybe we can encourage grapes to be there.
True.
Iceland in 2026,
Yeah.
where I'll
Yeah.
be.
The reference, this is
That'll be
what
a
the
popular place, no doubt.
Yeah,
ionosond map looks like at the moment.
Plan on coming home several days later.
right.
So I feel like we've got a very good grape distribution compared to that even in the US. Which is kind of proving the point that you can put a grape basically anywhere, but you can't
Yeah.
put it in most places.
I have one aspect of the eclipse that I thought I'd ask the group about.
Sure.
I've seen 2 eclipses previous totals. They both happen to be at solar minimum. This one was at solar maximum.
Mhm.
This was very different. It's a known thing that the corona is brighter and more compact at solar maximum than minimum. I wonder if anyone else had noticed that.
Yeah, I thought the corona display was relatively muted
Mhm.
compared to previous eclipses I've seen. I didn't think
Well,
of
muted
myself as
wouldn't be the term I
calibrated.
would use. It was small, but it was very bright, very
Well,
bright
yeah.
white.
We were
Yeah.
guessing here that it was because of thin cloud haze.
Yeah, maybe so.
I saw the 2017 one, of course, and then I saw one in 2006 in Turkey that both turn out to be at solar minimum. And this one is, of course, around maximum. And very, very different. In fact, my eyes saw it as a white halo around the moon. It was so
Mhm.
bright.
We saw sun dogs on either side. Actually, it was more than just the sun dogs, but it was almost a circle, and it was through the haze, atmospheric effect.
Ice crystals.
Yeah.
Yeah. I don't think we had that. We had the thin
Picture of the
haze come in, but then it dissipated during the eclipse itself. I was in Enosburg Falls, Vermont, up by the Canadian border.
Mhm.
That prominence near the bottom of the image was very visible in a standard hydrogen alpha equipped telescope here,
Well,
even
it's
though we were
visible
nowhere near
naked.
the path.
Yeah, well, it's visible naked eye.
That's delightful.
Well, I didn't
Very
have the
prominent prominence.
I didn't have the benefit of totality, and we
Yeah.
had lots of clouds here.
Right.
But the clouds cleared right at the end for a few minutes, and
Yeah, that prominence was covered at the beginning of totality. I was at center line, so it was a very distinct change of what was visible around the moon through the 3 minutes 30 seconds. But yeah, that was very obvious toward the end of totality for us. And this picture actually shows that white ring that my eye was picking up.
Did I hear some, again, media coverage that suggested that the moon was relatively far away from the Earth at the time of the eclipse?
Yes, that's correct. This was one of the longer ones.
Yeah, because I'm thinking that that ring, I mean, it looks like something very much brighter than the corona as I usually think of it.
Well, as I say,
Well,
it's
sort of,
brighter
you
and
know.
more compact.
Well, I'm wondering if it's more compact
The
or if it's
streamers-
just fallen off the range of the medium, where you have a very bright ring because you're actually picking up a bit of the solar surface.
No, that's not solar surface. That is the
Well,
corona.
surface was not a good word
But,
for it, but the technical language eluded me.
But
for the
having
moment.
seen it twice before with much more extended tendrils coming out, I was very surprised how short these were.
That's exactly what gets me. I
So
mean,
they would be
I'm
just
seeing
as
it
bright as this. They
drop
just-
all the way to black, and I'm wondering
Anyway,
if something has sort of thrown our range.
Well, we'll see how the pictures come out. The people who have taken wide dynamic range and stack it.
Yeah.
those will be very popular in the magazines and spaceweather.com.
Oh, yeah.
So, being with such distinguished people, correct me if I'm wrong, but won't we also be able to? I was looking at Christina's paper on some of the Doppler measurements and the Grape and everything, but won't we also be able to use these on a continuing basis? Maybe not a lot of frequent eclipses coming up, but with TIDs, the traveling ionospheric disturbances, and possibly the effect of some Earth-based earthquakes, things like that. Won't we also be able to use them with research with that, or am I in error on that?
I'd say you're 100% correct, Ron. In fact, I was just about to mention it. Just to keep in the back of their mind, if somebody has one of the Hamside grant supplied Grape 1s, DRFs, or one of the Grape 2s, if for some reason you're unable to keep it running on a potentially a 24/7, 365 basis, at least, say through cycle 25. If you want to return it to us, if you're not able to keep it running, there's no harm, no foul in returning to us, and we can redeploy them. We'd love to keep every single one of them on the air as much as practical. So that's just the right time to ask that question.
Yeah, because I would think there's going and who knows, there might even be something come up that everybody, like earlier this morning with what Nathaniel was showing, where people kind of go, huh, and then trying to do research on what that is. So So
We're
it
still
just,
going into solar max. We've got
Yeah.
solar flares, we've got aurora, we've got all manner of effects that will
Yeah.
continually be happening.
yeah,
I'm
yeah.
I'm
so
seeing quite a few dips in my original grape receiver here due to the solar flares.
Oh, yeah. And having just gotten a Grape 2, I'm just barely getting into seeing some of the information and the things that come out of it. But I am the citizen part of this citizen science group, as Nathaniel and Gary know so well. But just enthralled with all of this and looking forward. My Grape 2 does great, except every morning at about right around 7:20 till about 7:35. I seem to lose it, but other than that, it's doing great. All right, I'll go back in my corner.
Hey, that brings up, we probably ought to conduct a little business. There are, I think, 3 or 4 people who received Grape 2s, and their plan was after the eclipse to return the Grape 1 to Hampside so we could redeploy them. The original thought was just to return them to Case Western Reserve, and we'll figure it out after the eclipse. There was also talk of returning them for refurbishment, I guess, and redeployment to the New England Grape Group. We ought to figure out what we want to do, and if we can, put that in the minutes, and then we can let people know and proceed accordingly. So I don't know if there's any comment on that.
Yeah, I do have at least one person who emailed me and wanted to make sure that their Grape 2 is working all right before they redistribute their Grape 1. So if that's the case, then do reach out. But if you're otherwise inclined, if you think the Grape 1 is currently excess to your needs, since you have the Grape 2, you can send it back and we'll find another place for it.
We, the New England Grape Group certainly would be willing to support the Grape 1 DRFs, which, we're kind of familiar with. So,
So would you like them to send you back the
well, we haven't, I think somebody higher than our pay grade should make the decision what they want to do, but
well, if you're willing to do it, it'd be kind of convenient because you guys are familiar with checking to make sure it's in working order.
Just what is it? What do you propose, Bob?
well, Stan and I had talked about this. And there's some of these Grape 1s that I don't know what the number might be, but I got a feeling it's not very high, but maybe it's higher than I think. But we just thought, well, if they come back, we could, either receive them or they could be sent to us or whatever. I mean, from somebody else, from Gary.
Sort of a clearinghouse.
And then we'd check them out, and Gary would find a home for them or whatever, and they'd go back in service.
Got it. Cool.
We're kind of devoted to it. We'd like to see them being used.
Well, that would obviously be very helpful. And I know we can also probably count on having things that are missing, whether it's a power supply or a GPS antenna or something like that. So we've got to make sure that we can, Hampside, I would think one of our grants would want to cover the cost of replacement components and stuff too. But again, that's not
Yeah, well,
to make that decision, but just something we got to talk about. That's all.
well, just to, the point is to make sure whatever we send somebody, we have a good feeling it's going to work for them,
Yeah. Well, and it would be nice if the New England group could do it because you guys are really familiar with that hardware. You'd be able to look at it and be like, this is ready, redeployed. Whereas I would look at it and be like, I am not an engineer. I don't want to put Dr. Zorman on the spot or anything, but since John is in receive only at the moment, I will check maybe after the meeting and make sure that there's still shipping budget on the case side somewhere. And of course I can't put a call sign down yet because our esteemed dean does not have a call sign.
Thank you for pointing that out, Rachel.
As you are listening. Oops. I'll put myself down on that too. And maybe John, when he's available.
He has many other charms. It's all right.
Yes. Well, it is a problem that will soon be remedied. We have faith, Dr. Zorman.
Yeah, and many of you on the Zoom call heard me say it in person. So what can I do? I lose face. Probably my job if I don't get that call sign soon.
So how do we want to leave it? I think I would like to get the budgetary, I get the dollars and cents figured out too before we make a final decision. But tentatively, it'd be great if the New England Grape Group would participate. Right now, we know of 4, so it could be 4 to 6 or something like that. Would have to come in and go back out.
Yeah. I think we can certainly get that sorted and have a decision next week because I'd be willing to bet there's still budget left in deployment, but I also haven't seen it. I also know I just spent a lot on shipping. So
yeah, Rachel, we should do me, you and John, maybe David should do a catch up on the budget just so we can see where we're at.
Well, John does have the receipts, but it would be nice to level everything and see what's remaining because I do think a few more people will probably request magnetometers. Those are significantly cheaper to ship because they're tiny.
Right.
And they no longer need to be shipped at any kind of emergency 2-day rate kind of thing. So, yeah.
Okay, I'll reach out to the people who are planning on returning Grape 1s and just tell them to hang on to them a little while longer till we figure out where to ship them to. That's probably the best thing at this point.
Yes.
Yeah, you just don't want them to start sending them to multiple places. So.
Exactly. Yeah, that's right, Stan.
I prefer the plots from the old original Grape to the newer ones.
So do I. Easier to read.
Yeah, there are some definite advantages. Although the spectral data probably shows you a more complete picture because you wouldn't see any of these lines.
I'm relatively simple, and that simple two color graph really suits me nicely.
Yeah.
Yeah. But Grape data is very computationally usable.
It's very easy to look at your graph on the old FL digiplots and say, it ain't working.
That's right.
It's much easier from the doing stuff with the data side to be able to directly perform operations on this data.
You can see if you're in line with others that are watching the same ionosphere.
Yeah.
Just excuse me. Speaking for Grape 2, we're going to be completing the auto plotting for Grape 2 so that we'll see the same graphs as Grape 1 FL Digi, just for that purpose. And also we had to do a code freeze before the eclipse, but we will complete the auto start feature. I'm just speaking for myself, but John will determine when that will go out, and so that people can have their station restart in case of a power outage. We didn't quite get that completed before the eclipse, but it's still on the list.
Well, thank you.
Okay. Especially I should probably have an independent category here for DRF. Um, that's really for any kind of spectral feature. Okay. All right, so I feel like we're mostly done. Just wanted to point out that we have some stuff on the horizon. If you're planning to go to Dayton, Hamvention as well, it is tends to fill up very fast. If you need like to book or anything. All right. Any questions?
Yeah, so you touched on this a little bit with the data, but I think we should start making it a real point over the next couple of weeks to really hammer out our plan for getting the data back to a central location. So that we can start analyzing it. So maybe that can be a main point for next week's discussion.
Yeah. Well, and I think working the uploading programs back into like for the Grape 2s at the moment are mostly in raw data mode.
Right. Yes, I think we absolutely need to get that development of uploading the data to the main server going.
Right.
Yeah. But other than that, does anyone have any other questions, comments, or concerns? Because if not, we'll end about on time.
I've got a comment. Let me share my screen here briefly.
Sure.
And whoops, somebody else is sharing.
No.
Okay, I'm not sure what happened here, but anyway, I'm not used to this. Let me okay, here we go. The eclipse is very similar to what happened that morning. We've got the same down and up pattern, except in a smaller version. And that just reinforces my idea that what we're seeing is just a reduction in the intensity of the ionosphere due to the shadow.
Right.
It comes down and up in the morning for dawn, and then down and up. And it's actually, there's a little dip here and a little dip there, and there's a similar one over here. So those are very, very similar, just a few hours apart.
It's a new dawn.
Yes, exactly. And then over here you see the same thing with the later version of the Grape. So I'm running both here. Thanks much, everybody.
And so you're not, this is Stan. There was an email sent out, I think this morning. They're still querying on speaker for the Ham Exposition in Massachusetts coming up in August. You're not on the email list, Rachel, but Nathaniel and Gary are, so.
Rachel, are you able to give that talk? I think you're muted.
I should be able to. I believe that is right before the start of school, so I would be picky about doing it on a Saturday. But if it's not like the Sunday before school starts, because I would need time to travel. But as long as that's okay.
That's when you want to speak anyway. There's very, very few talks on Sunday. So Saturday is the big day.
Any other questions, comments, or concerns? I will say if you guys are interested in the minutes, because I saw Aiden asked in the chat, the minutes are There are hyperlinks in the minute documents to go back, as well as in the Grape Google group mailing, from what I've sent out links to them. If you have need to access like more aggressively, I do have like a table of contents file, so just drop me an email and I'll send it to you. Okay. Any other questions, comments, or concerns?
Well, I'll go ahead and just say, you know, just as a data contributor, I'm really interested in understanding some of these phenomena that are described as classic, but not really much explained, I think. So I'm wondering, you know, I'm not going back to the university, and I'm probably not coming back to Ohio anytime soon either. So how might I go about educating myself as to what exactly we think is going on in these classic patterns? Okay. Who's the author of that? I couldn't quite read that.
Here to there, radio
There's-
wave
there's-
propagation.
There's
Thank you, author. I
That
can't.
just
it's a
came
very
out from
distinct
ARRL.
group.
Okay.
Carl, whose name I never been able to pronounce, K9LA, some Dr. Nathaniel Frizzell, I don't think we've heard of him.
Oh, that guy?
Frank Donovan, Ethan Miller.
Oh, okay. No, that's fine. I just
Art,
needed
that's a brand new book
pointer.
from ARRL.
Yeah.
It's a good book. And it's,
Well, that's good. And I look forward to learning about all this stuff that seems very familiar, and yet I don't hear explained much.
It's a good, at a good level, I think. That's my opinion of the book, but
Okay, I'll wait to read that book before I interpret how I feel about that. But okay, well, I would just, you know, those of us who aren't, you know, cranking out papers and looking for grants and setting up conferences, kind of out on the periphery at this point. I would encourage y'all to keep us abreast as to what we're doing and why.
Okay.
Because so far my motivation has been pretty much altruistic, but I was hoping to score some practical tuition, since it's apparent that I can't trust my intuitions of a couple of years. But I'd like to replace it with, you know, more than anecdote.
Hey, Art. This is Ron, and just, I don't know quite where you're at, but I came in knowing absolutely nothing. I'm not even sure that I could have spelled ionosphere. And the Hamside group and all of the other people involved are a tremendous resource. There are some entry-level books, entry-level videos, all the way up to some more advanced stuff. You'll find that there is a ton of information, and I have found a lot of opportunities to, as Nathaniel knows, he has mentored me quite a bit to grow, stretch, evolve. It's been an incredible opportunity for an old guy in a medical field, not even in this kind of a field. So I know we're late. I just wanted to throw that out to you, Art, that there is just, it's just really, if you're a citizen science, they just create so much for you to do. And now Nathaniel's mentoring and working with me on learning Python and doing other things that I had never even heard of. So I'll be quiet, go back in my corner, but I just wanted to throw that out to you.
Okay, well, great, good. can't say that my experience has been exactly the same, but my situation is different. Yeah, I think, you know, it's, I don't know what level this question of how do we form that waveform in the ionosphere, is that an entry level question, or would it be addressed in an entry level text?
I'm uncertain what level you're coming in at, because
I'd be happy to, yeah, I'd be happy to tell anybody who asked.
Yeah. So what level are you coming in at?
Well, extra now, got my novice at 11. I'm 70 now, so broadcast engineer for many years before everything went digital. Now I'm mostly digital. I don't even know how, I don't know how to describe the levels. I'm not an academic, so I can't quote you a degree. Well, what's a good metric for that?
I don't know. Maybe a good way to do this is take a look at the book that Bob recommended and let us know, give us some feedback if that answers your questions. I can also send you some links of some papers we've written that talk a little bit more about the fundamentals of like the grape and what we're looking at. I can put those in the chat now, and they're
Yeah.
free to read.
I'm feeling like I've got a halfway decent grasp of the grape.
Okay. So
you can tell me if I'm wrong, but I think
yeah.
I'm interested in, I guess the basic question I have is, to what extent is the ionosphere, and that's a broad term, of course, to what extent is it material, and to what extent is it, well, ethereal, right? What causes these transverse waves? What causes the various effects we see during that classic bump? I'm particularly interested in the compression of the Doppler waveforms at the higher frequencies, which seems visually very very interesting to me. My sense is that most of the analysis needs to be statistical, which is why I'm stopping short, because you need the whole data set and a sense of the state of the art. But as I say, when I hear things and I ask about them and I'm told, well, that's the classic thing. Not to be unappreciative, but that's kind of not really informative. So depending on how you want to deal with your volunteers going forward, I would just suggest that that we might need to be engaged a little closer, so that if it becomes a question, you'll know who I am.
If you don't want to buy the book, K9LA has a very nice webpage. And has lots of write-ups on us on propagation.
And
there are others too, but that's one I can recommend.
Here's a link in the chat for a paper that Christina wrote, and it's called it talks all about the grape, and you can get it for free.
Right, looking at it, daily plots. Okay. I mean, this still, is there a section on eclipses in here?
I don't think.
Not really in that one. It's a great paper. Also, Dr. Tamitha Scove on her website has a whole bunch of presentations as well.
Right. Again, I'm not actually looking for a degree program here.
No.
My
Let me see if I can answer your.
My focus for the time being is kind of narrow. But I'm sorry, who was that?
Let me see if I can answer your question on the eclipses really quickly, in a way that, because where I say it's a classic signature, I can explain what I mean by that. First of all, with the Doppler shift, I think it's a good place to start with understanding how dawn and dusk works and how Doppler shift works. So the idea behind Doppler shift is that you have the transmitter WWV here, and you have a receiver somewhere else, right?
Okay, yeah.
Okay.
But I think I'm meeting you at a level maybe a little bit up from there.
Yeah, we'll get there in a second. So
Okay.
Just bear with me for a second. Okay, so you understand that part, right? Now, do you understand that if the ionosphere were to decrease, this signal path, the path length would increase as a function of time?
That would be what we've been measuring, right?
Yes.
Okay, I'm with you.
Okay, and then and that's what happens at nighttime, right?
Yeah, that's true. Certainly here at night and early morning, I see a very turbulent pattern.
But not only is it's not just turbulent, in general, the Doppler shift is negative in the evenings.
Okay.
Okay. The Doppler shift is negative in the evenings because the ionospheric electron densities are decreasing. And one possibility is that the path length is going higher as the ionosphere either decreases or goes up. And that creates a negative Doppler shift every night.
Right.
Okay. At dawn, the opposite happens. The ionosphere builds up, comes lower to the ground, and this path length gets shorter as a function of time.
That
Go
is,
on.
electrons are knocked off of oxygen atoms, so they become ionized.
Do you agree with that statement, Art?
Who, me? I don't know if agreement comes into it. I'm trusting you're telling me the science.
Okay.
You understand that concept.
So that's what we're seeing. So every morning we see an increase in Doppler shift, and every evening we see a decrease in Doppler shift.
Certainly, I've seen that every morning and evening since I put this thing in service.
Okay, great. And here's another example of that. This is showing 2 years worth of Grape data from measured in Cleveland at 10 megahertz. So 2 years is along the x-axis, 24 hours a day is along the y-axis. And this is showing that every morning you get positive Doppler shifts. Every evening up here, you get negative Doppler shifts. And so it's a very repeatable pattern. And you can even see the seasonal variability in there.
Yes.
Okay. So the eclipse signature, what you expect with an eclipse is like temporary dusk then dawn.
Yep.
Okay.
Negative.
Okay. So if an eclipse
Temporary
is temporary,
localized dusk and dawn.
Yeah. Right. Yes, you're right. It is a localized dusk and dawn. And so
isn't it all about
here,
collecting
this
data?
is what right here, this is what I'm calling the classic eclipse pattern that we've been seeing.
Right.
So
what I naively labeled the thumb. Right. I think.
Right. So classic dusk then dawn. So if the eclipse is like temporary dusk then dawn, then you would expect it to be temporarily negative Doppler shift followed by positive Doppler shift.
And there you have it.
And that's what we're calling the classic pattern.
Okay. All right.
Maybe CVS Pharmacy said.
Does that make it more clear now?
And help ensure your
Well, yeah, I mean, yeah, to be honest, I think I had inferred most of that.
That's all we're talking about when we say the classic eclipse Doppler pattern. That's all we're talking about.
I have a question, Daphne. This is Lawrence here. So basically what you said, this is the classical Doppler shift, but this is as a function of a single location. So does that mean that if you have a distribution of ionicides on Earth's surface, we would expect to have this pattern across all measurement stations, or we can see variations across these sort of stations?
That's one of the questions this research project is supposed to work on answering.
Okay.
I believe. Okay, so
All right,
that's
now
something.
now we're in the zone of the questions that I've been trying to pose.
Okay, so I think, some of the questions you're answering, Art, we don't have published yet. We're doing the work now to write those papers.
That is to say, the effort that the public here and the HempSci members have been involved in over the last 3 years is to collect data for analysis to see just what's happening, because that's really what science is about, looking at stuff and seeing if there's something that's funny, and then try to explain it. So this
Well,
is,
I tried that and I was told it was classic. So
Well,
now
I
I'm
think,
finding out a little more about what that means.
yeah. So when I say classical, I mean that I first saw a pattern like this. The first time I saw this sort of pattern was in 2017 when Steve Ryer, WA9VNJ, sent me some data that he did, not using a grape, but using essentially something equivalent that he had put together himself. And that was the first time I'd ever seen this sort of pattern relating to an eclipse. But now I've shown that slide many times. I've been talking about it for the past 6 years. And so that's why I call it classic, because I've shown it so many times. But
Yeah,
yes,
there's always a gray zone between familiarity and understanding.
Right. And so for a lot of the people, a lot of the people who come on this Zoom call, they're coming on every week. And so they're also used to seeing it. So this is what we are calling the classic pattern. Whereas something like something like this, which is very different from what we've been talking about for the past 6 years, I'm calling a strange pattern.
Okay. Nathaniel, I have another question. Can I?
Yeah.
When we talk about when we talk about these type of measurements, and when we talk about the frequency in the ionosphere, I'm trying to get my head around the geometry of this ionosphere, because surely the geometry would impact the propagation of signals. And what I mean by that is that if you have a particular signal in the F2 layer, does that mean that the frequency is uniform across all locations on Earth? Does it vary by much, or is it pretty constant, or is it sort of random? Does it stay within any boundaries? I mean, if you can recommend some papers on this particular topic, I mean, I can read about it.
So again, so when you're saying the frequency remains constant,
so let's say, for example, so let's say, for example, you are in Houston, Texas, and you have one, and the distance between two ionosones is about, let's say, 1 kilometer. Would you expect that the F2 frequency, the critical frequency, to be the same with this distance, or it varies by much?
Oh, okay. I see. You're trying to look at spatial scales in the ionosphere. I would say it, on a median sense, it doesn't vary too much. Well, if you go to prop.kc2g.com, he's got some very nice maps that show roughly our understanding of ionosons and the critical frequencies. So you can see these iso contours here. But this is like kind of like the median or the smoothed values. So, going a kilometer apart over, say, in Texas, you're probably going to be around 26 megahertz. But there's going to be some smaller scale variations on top of this. And actually, that's a lot of what where some of the very interesting research topics are. Like on top of this smooth like background, there's wave-like structures called traveling ionospheric disturbances. There's all sorts of very, very short-term variability. So it's very noisy. So statistically, like if you measure it over an hour or so, a kilometer apart, they'll probably be similar. If you measure from minute to minute, you could get some wildly different measurements.
Very volatile. Okay, so when we talk about Earth location, we can basically get the longitude and the latitude and elevation above sea level. And if we want to find the location on curved space, we can use the geodesic formula. Just theoretically speaking, if we're looking at this frequency, is there any paper talking about trying to basically come up with some sort of formula to basically look at distances within the ionosphere? So just for simplicity, we assume it's just a plane, just like a flat surface, and we can just look at basically the distances between 2 points in the ionosphere. Is that something that could be? The reason for that is because you can map the location to the frequency. So you have a location on Earth, then location in the ionosphere, and in that location you'll have a frequency. And if you move left or right or whatever, as you said, like it moves sort of with distance, you can get different volatile frequency in the short term.
There's lots of papers looking at this sort of thing and trying to map it out. Here's a paper I wrote a couple of years ago.
Okay.
And this plot, if I can download this, you see this little map right here?
Yeah. So that's the GNSS.
This is delta total electron content units measured by GPS receivers on the ground. And you can see how much it can vary in space.
Okay.
And so there's a lot of, again, this is like a very, very hot like research topic, understanding this small scale variability.
Okay.
So there's lots of
it seems like a ray tracing problem.
It is.
Well, but for the ray tracing, you need to have an ionosphere that is sufficiently capturing all this variability that you're talking about. And most of the ionospheric models we have are really quite smooth. They really don't have all the small scale variability in there. So a lot of the models don't really capture all of this.
I'm suspicious of models, but I do like data.
What you said about this sort of short scale variability sounds to me like the stock market, because if you look at the closing price from one day to the next, it doesn't move much, because in probability theory we call it Markovian. But if you look at intraday trading, it's extremely volatile. But at the end point, so it's something. Yeah, I see what you mean. Okay, I'll definitely have a look at those papers. There, it's where my mind is heading. Nothing else. Thank you for that.
Yeah. So I mean, if you go to scholar.google.com, you type in small scale ionospheric variability. That's probably something good to search on.
Would anyone like to venture a summary?
A summary?
Yeah, what was your takeaway from some of these papers? This is a ham radio operator's question, right? It's purely a functional level, not really physics.
It's always changing. That's the best. That's right. The best thing I think you can say about it.
I think
it'll change.
Another way to explain it might be to say that when we study this small scale variability, we often try to separate it out into the different types of things that can cause this small scale variability. We try to look at one thing at a time and try to understand that. So for instance, this particular paper that I wrote looks at large scale traveling ionospheric disturbances. So my whole paper, even though there's all this like smaller scale stuff going on in here, I'm really only paying attention to this one bigger hump here.
Yeah, that's what I was thinking. A lot of these seem to be matters of scale.
Yes.
You know, the lovely thing about the eclipse is it's got a scale substantially different from that of most of those stochastic sort of, oh, sorry, that's not a ham radio word. The random or pseudo-random components.
We appreciate
Fluctuations.
stochastic.
Yeah.
So yeah, you're right. It is the eclipse absolutely is a different scale size from many of the other things that we're looking at.
Okay.
So I think I need to go on to my next call or my next student meeting right now. But I hope those were somewhat useful resources. I will see some of you people at 4 o'clock today for the SDQP Telecon. And thank you so much, everyone.
Okay, 3.
Thank you.
So long,
Thank you.
everybody.
So long. Bye-bye.
7-3.
Bye. 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 Bye.
73.